So welcome back to the next session, my dear friends. So in the previous session we are discussing about the alkalinity and how to measure alkalinity using titration technique and what are the relationships between the different kinds of alkalinities upon the variation in the phenolphthalein methyl orange indicators quantity of titrant, okay, in different range of titrants. See now I told you that generally alkalinity is negligible for drinking water. Caustic alkalinity is negligible for drinking water. I told you, and I told you that I will explain you theoretically. I will explain it now. And in the previous session I told that what are the ill effects, bad effects of the alkalinity and acidity also, and what is the range I have told you already. So generally when the water is alkaline, that means it is having CO3 2 minus, it is having OH minus ions in it, right? CO3 2 minus or HCO3 minus, whatever it may be. So it is having some kind of ions like that. So these CO3 2 minus will react with the metallic ions present in water. So like Ca2 plus, if it is present, then it will form a precipitate of CaCO3, which is a precipitate. Similarly, so if OH minus alkalinity is present, if it is reacted with Mg2 plus, then it forms a precipitate of MgOH twice. Similarly, if this OH minus is reacting with iron, so again it also forms FeOH thrice, Fe2 plus or Fe3 plus. So these are all precipitates. So these precipitates in a distribution network, if this is a pipe, so it will form a kind of incrustation. So it's scaling. So the aperture will get reduces. So these precipitates will settle down on the surface of the pipe conduit. So pipe opening. So reduces the section, and because of this reduced section, the pressure inside the pipe will increases, causes the collapse of pipe also, and sometimes desired amount of water may not be traveled, may not be distributed because of this reduction in the surface, in the cross sectional area. So this is nothing but incrustation. This is called incrustation. Incrustation is the problem caused by alkaline water, and when the water is acidic, so it causes corrosion. So when the water is acidic, it causes corrosion of pipe, and pipe gets eroded. Okay, pipe also gets eroded. So generally the range of alkalinity I have told you, the range of pH is also present for drinking water. pH range for drinking water should be in between 6.5 to 8.5. 6.5 to 8.5, there is no relaxation in this. So alkalinity, there is relaxation. Alkalinity should not be more than 200 mg per liter for ideal source, and it is relaxed up to 400 mg per liter. But there is no relaxation for pH of the water. So this is all about alkalinity. And now we are moving on to the next concept, that is hardness. Hardness of water. Very, very important concept for GATE examination. This is a very, very important concept for GATE exams. Hardness and alkalinity. So every year, at least 2 marks or max 4 marks also we can expect from these concepts of alkalinity as well as hardness. Next is hardness. See, what is meant by hardness? What is meant by hardness? Alkalinity is caused due to negatively charged ions present in water, whereas this hardness is caused due to multivalent cations. Multivalent cations. So, multivalent cations means generally calcium, magnesium, aluminum, iron. So, likewise, there are many multivalent cations present in water. So, any of the multivalent cation, okay, can cause hardness. But I told you, we only consider calcium and magnesium because majorly the water contains major cations present in water is calcium and magnesium. So, in general, hardness is caused because of Ca2 plus, Mg2 plus, Fe2 plus and Mn2 plus, Sr2 plus. So there are many cations which may cause the hardness when they combine with carbonate CO3 2 minus, HCO3 minus, Cl minus, SO4 2 minus. So when these multivalent cations react with any of these anions, these multivalent cations react with any of these anions, they cause hardness. They cause hardness. It causes hardness. Okay, it causes hardness. It causes hardness. So predominantly, I told you again, so these multivalent anions are negligible. These are negligible. So these are predominant. So that is why generally we take only the concentrations of calcium and magnesium to determine the hardness of water. Okay. So again, the hardness is of two types, permanent and temporary. So we will discuss it. So before going into that, I told you that I will explain why the OH minus alkalinity is negligible for drinking water. So I forgot to explain that in this session. First I will complete that and I will enter into hardness. Okay. So why OH minus is negligible in drinking water? OH minus alkalinity. Why OH minus alkalinity is neglected in raw water when the pH ranges from 6 to 8. Okay, when the pH ranges from 6 to 8. So let us take the pH as 8. Let pH is equal to 8. pH is equal to 8 means what is the H plus ion concentration here? So this is equal to minus log base 10 H plus ion concentration, right? So now H plus ion concentration is nothing but, that implies H plus ion concentration is nothing but 10 to the power of minus 8 mole per liter. Okay, 10 to the power of minus 8 mole per liter. Now this is H plus ion concentration. We know that the product of H plus ion concentration and OH minus ion concentration is equal to 10 to the power of minus 14. That means OH minus ion concentration from this is equal to 10 to the power of minus 6 mole per liter. Mole per liter. So this is in mole per liter. We can convert this in mg per liter. So OH minus concentration in mg per liter is equal to OH minus concentration in mole per liter into molecular weight gram per mole into 1000, right? Now OH minus concentration in mole per liter is 10 to the power of minus 6. Molecular weight is what? OH minus molecular weight, O is 16 and H is 1, that means 17. So the molecular weight of OH minus is 17, so it is 17 gram per mole multiplied by 1000 to make it milligram. So now the value is 10 to the power of minus 3 into 17 mg per liter, right? This is mole per liter. So this mole get cancelled, this gram has become milligram per liter. So this is when pH is 8, so this is the OH minus concentration in mg per liter, that means 0.017 mg per liter. 0.017 mg per liter. Now if I convert this in terms of CaCO3, okay, this is in terms of OH minus. So converting this into terms of CaCO3. So caustic alkalinity, OH minus alkalinity as CaCO3, which is equal to, so the concentration, so this is the concentration of X, 0.017 multiplied by equivalent weight of Y, that is 50. So what is the equivalent weight of X? That is this one. Equivalent weight of this is, so this is 17 is the molecular weight and the charge is 1. So equivalent weight again it is also 17. Equivalent weight is also 17. So 17 10 to the power of minus 3. So what is the concentration? So concentration is now, it is becoming 0.05 mg per liter as CaCO3. So when pH is 8, this is the concentration of OH minus alkalinity. Can we neglect this or not? So 0.05 is a considerable value? No. So when pH is 8, it is 0.05. When pH is 9, for example, when you convert this, so it is 9 now, then this will become 9. If this will become 9, this will become 5. If this becomes 5, this becomes 5. If this becomes 5, this becomes 2. If this becomes 2, this will become 0.17. This will become 0.17. If this becomes 0.17, this becomes 10 to the power of minus 2. So if this becomes 10 to the power of minus 2, it becomes 0.5. That means if pH is 9, it is becoming 0.5. pH is 10, it becomes 5. So that means when the pH is more than 10, so pH is 10, then it is 5 mg per liter. That means when the pH is more than 10, then OH minus alkalinity is considerable. Otherwise, it is not at all considerable, it is very negligible. So generally the working range pH of raw water varies from 6 to 8. That is why we generally neglect the OH minus alkalinity. This is the reason. So this is a theoretical explanation why we neglect the OH minus alkalinity in raw water. Okay. So when pH is more than 10, then OH minus alkalinity we need to consider. But in this range, so in this range, I have told you that is why the range of pH OH minus alkalinity varies from 14 to 10 to the power of 10 to 10.2. This is the reason. When it is 10 only, it is becoming 5. So that is considerable. Otherwise, it is not considerable. That is why up to 10 to 14, OH minus alkalinity is considerable. Below 10, it is not considerable. Okay. Now, let us come back to the hardness. So the hardness is of two kinds. One is temporary and one is permanent. Similarly, we can also call it temporary hardness. We call it as carbonate hardness, and the permanent hardness we call it as bicarbonate hardness. Sorry, non-carbonate hardness. Non-carbonate hardness. It is not bicarbonate. It is non-carbonate hardness. So total hardness is because of Ca2 plus majorly, Mg2 plus so carbonate hardness, it is because of CO3 2 minus and HCO3 minus. So this is carbonate hardness plus non-carbonate hardness. Non-carbonate hardness that is Cl minus SO4 2 minus. This is non-carbonate hardness. So here when we want to find the hardness, if we find the concentration of Ca2 plus and Mg2 plus, we will get the total hardness. Okay, to determine total hardness, the concentration of Ca2 plus and Mg2 plus is needed. So by doing titrometry, titrometric procedures, we will determine the Ca2 plus and Mg2 plus concentration. Now we got total hardness. So to know the carbonate hardness, to determine carbonate hardness, it is necessary to determine alkalinity. It is necessary to determine alkalinity. So if you want to determine this carbonate hardness, we need to determine the alkalinity. Once we know the carbonate hardness, okay, that means total hardness is equal to carbonate hardness plus non-carbonate hardness. If we know the carbonate hardness, that means non-carbonate hardness is equal to total hardness minus carbonate hardness. But how to find carbonate hardness? How to find the carbonate hardness? See, very, very important this is. See, carbonate hardness may be due to CO3 2 minus and HCO3 minus, but the anions, these are the anions, but the cations may be sodium, calcium and magnesium. 3 can be present. See, listen carefully. Total alkalinity. Total alkalinity means it is because of Na plus, Ca2 plus, Mg2 plus CO3 2 minus and HCO3 minus. Here alkalinity is because of CO3 2 minus and HCO3 minus. So these anions may have magnesium as a cation or calcium as a cation or even sodium as a cation. But this sodium cation does not cause hardness. This sodium cation does not cause any kind of hardness. Now if you find alkalinity using these two, this is not the count of carbonate hardness. It is not the measure of carbonate hardness because this alkalinity is also having some part of sodium. So this sodium is not causing hardness. That means if we find total alkalinity, it does not mean that this total alkalinity is equal to carbonate hardness. this total alkalinity is equal to carbonate hardness. But if there is a non-carbonate hardness, that means if there is non-carbonate hardness, that means we are having Cl minus and SO4 2 minus. If in water these two anions are present, these anions will attract the sodium, and the affinity of sodium ion to get and to react with these two non-carbonate compounds is more than CO3 2 minus and SCO3 minus, because these are weak reactions. Here, when these two are present, then this sodium will break the bond with these two and go and react with these two. Listen carefully. When in water non-carbonate hardness is present, that means these anions are present, then the sodium will not continue its bond with these two. It will break the bond and go and react with these non-carbonate anions. Now in that case, when non-carbonate hardness is present in water, that means sodium will no more be present in alkalinity. That means in that case, when non-carbonate hardness is present, we can safely assume that total alkalinity is equal to carbonate hardness. But when this non-carbonate hardness is not present, then total alkalinity may also contain sodium alkalinity. That means total alkalinity is more than total hardness. When non-carbonate hardness is not present, it is not at all present, remove this. In that case, this total alkalinity count we are calculating from sodium, calcium, magnesium 3. That means total alkalinity will be more than the concentration of Ca2 plus and Mg2 plus. This is total hardness. I told you that total hardness we calculate from these two. Total alkalinity we calculate from here. So when the total alkalinity is more than total hardness, that means non-carbonate hardness is not present. That is why sodium is present here. If total hardness is equal to total alkalinity, or total hardness is more than total alkalinity, that means there are surplus calcium and magnesium are present. There are surplus more. That calcium and magnesium is present here. Are you getting what I am saying? So when a non-carbonate hardness is absent, then total hardness may be less than or equal to total alkalinity, or vice versa. That means when we can write the same thing in vice versa. When total alkalinity is greater than or equal to total hardness, then non-carbonate hardness is equal to 0. When total alkalinity is more than total hardness, then non-carbonate hardness is equal to 0. Then carbonate hardness is equal to total hardness. Carbonate hardness is equal to total hardness, because total hardness is what? What is meant by total hardness? Total hardness is equal to carbonate hardness plus non-carbonate hardness. When this non-carbonate hardness is 0, when this is 0, that means total hardness is equal to carbonate hardness. And similarly, when total alkalinity is less than total hardness. When total alkalinity is less than total hardness, that means then the carbonate hardness is equal to total alkalinity. Carbonate hardness is equal to total alkalinity, and non-carbonate hardness is equal to total hardness minus carbonate hardness. Total hardness minus carbonate hardness. Very, very important. These relations are very, very important for the examination. So non-carbonate hardness is equal to total hardness minus carbonate hardness. So let us write this clearly now, and then we will write the formulas to determine the hardness also. So we already know the alkalinity formulas, and we need to write the formula for hardness now. So once we know the formula of hardness, once we know the formula of alkalinity, we can easily find anything, that means carbonate hardness, non-carbonate hardness, total hardness, anything we can determine. Let us write it clearly now. So total hardness is equal to carbonate hardness plus non-carbonate hardness when total alkalinity is greater than or equal to total hardness. When total alkalinity is greater than or equal to total hardness, then total hardness is equal to carbonate hardness, total hardness is equal to carbonate hardness, and non-carbonate hardness is equal to 0. When total alkalinity is less than total hardness, then total alkalinity is equal to carbonate hardness, and non-carbonate hardness is equal to total hardness minus carbonate hardness. How to find total hardness? Total hardness, so let us write it clearly again. So total hardness in mg per liter as CaCO3. Total hardness in mg per liter as CaCO3 is equal to, so Ca2 plus concentration. So total hardness we calculate from calcium and magnesium side. So we calculate total hardness from cations side. So Ca2 plus is the concentration of X. In terms of Y, I need Y is CaCO3 into equivalent weight of CaCO3 by equivalent weight of Ca2 plus Mg2 plus in mg per liter multiplied with equivalent weight of CaCO3 by equivalent weight of Mg2 plus. So we already know the equivalent weight of CaCO3. So the equivalent weight of CaCO3 is equal to 50. So equivalent weight of Ca2 plus, that means the molecular weight of Ca is 40 and the valency is 2, that means 20 is the equivalent weight of Ca2 plus. 20 is the equivalent weight of Ca2 plus. Similarly, equivalent weight of Mg2 plus. So the molecular weight of Mg is 24. So the valency is 2. That means it is 12. The equivalent weight of Mg2 plus is 12 gram per mole. So here This can be written as Ca2 plus mg per liter multiplied with equivalent weight of CaCO3 is 50 by equivalent weight of Ca2 plus is 20. It is 20 plus mg2 plus in mg per liter, equivalent weight of CaCO3 is 50 and equivalent weight of mg2 plus is 12. mg2 plus is 12. Okay, so using this formula, so we can find total hardness. So total hardness is equal to total hardness mg per liter as CaCO3 is equal to Ca2 plus mg per liter into 50 by 20 plus mg2 plus mg per liter into 50 by 12. Similarly, what is total alkalinity formula? Total alkalinity as CaCO3 in mg per liter, CO3 2 minus mg per liter into 50 by 30 plus HCO3 minus mg per liter into 50 by 61. So these are the formulas of total hardness and total alkalinity. Total hardness and total alkalinity formulas. So from here we can find the concentrations, right? So how to measure it using titration? So how to find total hardness, that is concentration of CO2 plus and Mg2 plus using titration technique. What is the titrant we use and what is the method we use? So let us see. So the titrant we use is EDTA. So the titrant which we use to find the hardness, the titrant which we use to find the hardness is EDTA method. So method to determine hardness. EDTA. EDTA means ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid, which is we call it as versanate. Versanate solution, we call this as versanate solution. We call this as versanate solution. So we also use the indicator here. Ethylene diamine tetraacetic acid. So we use versanate solution, that is also we call it as versanate method, and endpoint indicator EBT, Erichrome black tea. So is the endpoint indicator which converts from wine red to blue during this working range. During the working range, it converts from wine red to blue. Okay, when titrating with EDTA, so when the color changes to blue, on addition of EBT, that means there is no hardness, so that the hardness is completely exhausted. So when it is in wine red, that means it is in hardness is present still. When it converts into blue, then that means hardness is absent. Okay, so generally hardness, what is the bad effects of hardness is, so the major bad effect of hardness is increase in soap consumption during washing of clothes. Okay, bad effects of hardness. Increases soap consumption and it causes a bitter taste. The taste of water changes, it becomes bitter taste, and scaling, especially when the water is fed into boilers. Scaling of boilers, it's a very serious problem. So see, hardness is very critical in case of industrial water supply rather than domestic water supply. As I told you, scaling of boilers may lead to boiler burst. So the blast furnaces may have uneven contraction and expansion because of this scaling, because of which sometimes they may fail. So industrially this hard water is more critical, so than in our drinking water, domestic water. So that is why generally the hardness is, we only need soft water for industrial water supply. So it is classified, the water is classified into different categories depending upon the hardness. When the hardness is in mg per liter as CaCO3, when it is less than 75, we treat that water as a soft water. So this is called soft water. Okay, and when it is in between 75 to 115, this is moderately hard. It is moderately hard water. And if it is 115 to 300, this is hard water. More than 300, very hard. But as per IS 10500, as per IS 10500 2012, so for drinking water, it should not be more than 200. For ideal source, and it should not be more than 600 under unavoidable conditions. So the relaxation was given only up to 600 mg per liter, not beyond that. Okay, so this is about the hardness. And we are going to discuss about some kind of small kind of chemicals like chlorides, nitrogen, fluoride, and some kind of metallic ions such as iron, manganese, copper. So all these things we are going to discuss in the coming class. So there are some limits of chlorides, sulfates, fluorides. So all those things are very, very important. Dissolved oxygen also, there is some limitation for dissolved oxygen also. All these things, limits are very, very important, and the hardness is damn important for examination. Hardness and alkalinity, these two conceptually you need to be very clear in these two concepts majorly from this topic especially. Okay, we can expect 2 to 4 marks from this concept. Okay, so we are going to continue the same thing, the chemical properties of water, chemical impurities of water, in the next session too. Thank you so much.